presentation for my class. I will record and I will put the recorded version inside the ULearn under my name. Okay. Actually, this is my part after Dr. said, which is the third chapter. We will begin with multivariate data analysis. Okay. So, first of all, my name is Zuraini binti Osman. Okay. Welcome to UTM MTDS. Most of you, this is your first semester, right?
Yes.
Okay. Yes, doctor. Okay, actually we can make this session interactively because we are 8 p.m. Okay, if you have question you may ask. Okay, for beginning I will introduce myself. My name is Zuraini Osman. Actually, we are from I'm not in computer science background, but my PhD in artificial intelligence, which is my majoring is in image processing. Previously, my first degree in applied maths, which is computer modeling, and I further my study for master in applied math also, applied science in USM, and just finished my PhD in image processing, artificial intelligence majoring. Okay, now, so if you are not in the computer science background, actually it is the same situation with me because this is the new thing that I learned, but I found that inside the artificial intelligence study and for specifically in the data science, there is a lot of mathematical involved. It's not like a lot of fundamental, but we applied it in this area. For example, this statistic. Okay, in analysis, we usually use the statistical test to know that our study is accurate enough or valid enough or it is reliable compared to other study or not. Okay, how can we compare it? We have to use the statistical measurement. Okay. Before we start, is there any question? Actually, I found Aiman, you are from ni kan? Aiman diploma
Yeah.
student for for my class. Actually,
Yeah.
previous for the diploma and degree, I teach calculus, linear algebra, discrete mathematics, and for this MTDS, I teach statistics. Okay. Hopefully, if there is elective about image, I want to involve also. Okay, for now, I will involve in statistics. Okay, so let's begin with our first chapter. Okay, this is the slide introduction to multivariate data analysis. Can you see the slide?
Yes,
Yeah.
doctor.
Okay, so let's begin. Okay. Introduction to multivariate data analysis. Okay, so this is the learning objective, which is for this chapter. End of this chapter, we should able to do the following thing, which is explain what multivariate analysis is and when its application is appropriate. Define and discuss the specific technique included in multivariate analysis. Determine which multivariate technique is appropriate for a specific research problem. And discuss the nature of measurement, scale, and their relationship to multivariate technique. finally describe the conceptual and statistical issue inherent in multivariate analysis. I'm quite sure you are already involved in analysis. For example, in the statistic, if we do the survey, then we have the data and we analyze the data. From the data, we can conclude something. That's the analysis that we done. Okay. What is multivariate analysis? Okay, multivariate data analysis is all statistical method that simultaneously analyze multiple measurement on each individual or object under investigation. Okay, we use the multivariate to do a test for the sample. Okay, for example, if our sample is graduate alumni, which is you want to measure her or his employment after they finish their study, and what's the data that involved for that particular person. This person, we call it as on each individual or object under investigation. That's person that we want to investigate. And then for that particular person, it involves variable to measure. Okay, why use this multivariate analysis? Okay, why use it? We use it because of to measure something, to explain and predict something, and hypothesis testing. For example, for explanation and prediction, while using the graduate employability punya data, we want to predict that is this course is still valid for the next 10 years? That's why we are using this multivariate data analysis to that particular person, which is the graduate. It's the graduate as our sample. Okay. Is there any question? Okay, can we move? Okay, if you have question, you may ask in the chat or you may open your mic. Okay, then this is the basic concept of multivariate analysis. If I mention something wrong, you can also correct me, because I'm also a person that still have some fault in me that someone have to correct me. Okay, boleh. And this is the basic concept of multivariate analysis. In this multivariate analysis, the important thing, the basic thing that you have to know is the variate. And this is the measurement scale, which is the measurement scale involved is non-metric and metric. And other than that is multivariate measurement and measurement error and type of technique. Actually, this chapter is introduction to multivariate analysis. We will review what is the multivariate analysis and what the technique will be used in this analysis. We won't do more deeper in one technique to another technique, but we will cover all the thing, which is like a overview for this analysis. Okay, then the variate. Okay, the variate is a linear combination of variable with empirically determined weight. Then weight are determined to best achieve the objective of the specific multivariate technique. And this is the variate equation. Okay, y prime. Okay, this is not the differentiation. This is the variate equation. Y prime is equal to W1, X1. Okay, W1, W2, and Wn. It is the weight for variable X1. W2 is the weight for variable X2. And so on until Wn is the weight for Xn. Okay, each respondent has a variate value. Okay, the variate value is a linear combination of the entire set of the variable. It is dependent variable. Okay, first I want to ask, did you still remember what is dependent, what is independent variable? What is it? Apa tu? Can Someone please explain? Okay, if you don't we just recap back what we learned in the SPM level. If it is involved graph, this is graph X versus graph Y. Which one is dependent variable? Which one is independent? Which one is dependent variable? The Y value is a linear combination of entire set. If we have this kind of graph, this graph is garis lurus, linear graph. Y is equal to mx plus c. Okay, x is independent or dependent variable?
Independent.
Correct. And y is
Dependent.
dependent. Okay. The simplest the simple example is this is the x value, and this x value can be 1, can be 2, can be 3, 4, and so on. And this is independent. It is not depend on other value. It is independent. Dia boleh berdiri dengan sendirinya. Okay, and this Y is dependent. Okay, why I said that this Y is dependent? Because this Y value, we can find Y value after we put the X value here. It depends on the X value. So the Y value will depend on X value. Okay, for this graph, we know that independent variable come from the X value and dependent variable come from the Y value. If we have the data, for example, taburan hujan in Selangor, then Johor, Pulau Pinang, then other state like Kedah, apa semua tu kan. Then this is as our X, and our Y is the volume of hujan. Okay, we know that this Y value is depend on each state. It will differ from one state to another state. Then we know that each state is independent. Selangor, it will not depend on other value, but this the taburan hujan will depend on the state. Okay, clear? Then this is the potential. Okay, this is the potential independent variable, which is income, education, family size. This is independent variable. If we want to make graduate employability as our variable, and the independent variable will be the gender, the course that he take. Other than that, like the this graduate from the state of this alumni. Okay. Then we go for the next, which is type of data and measurement scale. Okay, we have data. If we want to do analysis, we have to we have to do analysis after we do analysis after we found a data, right? Okay, for example, this data, the type of data will be non-metric or qualitative. The other type is metric or quantitative. Okay. Non-metrics is like nominal scale, ordinal scale, and for metric, which is quantitative, is interval scale, ratio scale. Actually, this kind of data, if you involve in survey, what type of data that you will use? Okay, but if you are in image, for example, image processing, we have also data. It's it's not like we found this is the one image, but inside this image we have data for each pixel. This also represent a data for each pixel, and for that particular pixel, we can make a parameter. For example, we want to know the sharpness, the intensity for that particular image. Okay, then for I will take image as an example because I'm in this image area, and for this particular image we can measure using qualitative and quantitative. But from this one image, we can measure by using the survey. We have to measure by using its particular value from the pixel. Okay, what is the qualitative measure for the image, for example? And what is quantitative measure for the image? Okay, qualitative, it's like quality of that particular image. Is this image is free from the noise, or it is the sharp image. Okay, it represent it qualitative. But if you want to measure the quantitative, whether this image that we found by using our proposed method is accurate enough, we want to measure it by using the accuracy, and we measure it by using quantitative measurement, like for that particular image, the measurement for the quantitative, like we have to find it by using figure of merit measurement, or we have to find it by using F measure. Actually, F measure is also found the accuracy, the true positive, true negative for that particular image. But this kind of data is normally found by using survey. By using survey, or survey for that for what objective that we want to do. But what I mentioned just now is in terms of image. It will dia boleh macam, it can be, we can suit it what is our problem, and it's depend on us what we want to measure. Okay, and for this is the measurement scale for this data, which is non-metric, which is nominal, ordinal, metric, interval, ratio. And after this, we look at what is nominal, ordinal, what is interval, and ratio. For non-metric, nominal is size of number, is not related to the amount of characteristic by measured. And for ordinal, a larger number indicate more or less of the characteristic measure, but not how much more or less. And for this metric, the type is interval, contain ordinal properties. In addition, there are equal difference between scale and point, and ratio contain interval scale properties. In addition, there is a natural 0 point. Okay, for the note here is the level of measurement is critical in determining the appropriate multivariate technique to use. Okay, do you understand what is nominal, ordinal, interval, ratio? Okay. If you're not understand, I'll bring the example here, which is what is nominal scale. The first one, nominal scale for the non-metric. Okay, this is if we have the nominal scale, we want to categorize. It uses a label variable in different classification and does not imply a quantitative value or order. And we want to measure whether it is A or B. This is nominal scale. And the number two for the other type of non-metric is ordinal. Okay, for this ordinal scale, for the user satisfaction with our service, this is what we call the ordinal scale. Actually, I'm quite sure that you are already involved in this nominal scale, in this ordinal scale. It is used to represent non-mathematical ideas such as frequency, satisfaction, happiness, a degree of pain. Okay, this is ordinal scale. Okay, and interval scale. Interval scale is in the metric category. Then for this interval scale, we want to measure defined as numerical scale. For example, we want to rate from 1 to 7 for your experience, where the order of the variable as well as the difference between this variable is known. Okay, it has order, which is 1 represents something, and 1 represent very unsatisfied, and 7 represent very satisfied. This is what we call interval scale. Okay, in the data for the metric. And for the metric, another scale is ratio. We rate, we put it in the range. For example, how many hamburger can you eat a day? Between 1 and 2, between 2 and 3, between 4 and 5, more than 5. It's variable measurement scale that not only produce the order of variable, but also make the difference between the non-variable along with information about the value of the true zero. Okay, normally we found the ratio scale in the survey, like they want to know our income, annually income, right? They put inside the range from berapa ratus to berapa ribu, right? This is in the scale. And for further example, for this nominal, ordinal, interval, and ratio, you can find inside this link. I'll put the slide link. Okay, let me see. This is the quite slow in my question for. Okay, you may see from this slide. Okay. Okay. Level of measurement in statistics. This the example that I used just now is from this website. And okay, this is the example. Apple. Okay, this is nominal scale example, gender, political preference, and place of residence. Okay. Then you can go through this notes. Okay. If there is something in the slide that you don't know what is mean, you may find inside the you may search in the internet, because I'm quite sure for me the statistic I learned it in a first degree, then quite long time to teach statistic again, so many things to forget. Then okay, back to our slide. So far so good.
Okay, good.
Okay, so just now someone mentioned that there is problem. Okay, simply said that is my network got problem, or is it from me?
Yeah, I do not know because
Okay.
the screen is actually freeze. Sorry.
Okay, it's okay. What can I call you? Simply.
Yeah, you can just call me
Okay.
Sim.
Okay, Sim. Actually, you may see my recorded version if you are the internet connection is problem for your area.
Okay.
But if the problem from me, then we can wait. We have to wait.
Okay. Sorry.
Okay. It's okay. Okay. Then this is the measurement error. What is the measurement error? All variables have some error. What are the source of error? Okay, first is measurement error. It is distort observed relationship and make multivariate technique less powerful. Okay, this is the error. It's like something like if we learn physics, we want to take the, we want to make a accurate something we want to make a accurate tool, we have to measure, is there any error? It seems like that situation, which is in analysis also. We have to uh, we have to measure, is there any error in our analysis? Okay, if it involve error and it make our multivariate technique less powerful. Researchers use summated scale for which several variables are summed or averaged together to form a composite representation of concept. Okay. Then this is measurement error. In addressing measurement error, researcher evaluate two important characteristic. Okay, like it is something like if you learn physics in the secondary school, it's something like that, which is in the first part in the tak tahulah, I'm not sure sekarang punya syllabus, but yeah, when I take the physics in SPM, first chapter the chapter that I learned is accuracy, validity, reliability. In bahasa Melayu masa tu the textbook is kejituan, kepersisan, something like that. That's also involved in this statistic, which is we want to know the validity of our study and the reliability of our study. What is the validity? Okay, sometimes we hear that other person claim that this study is not valid. Is not valid. Why they have to why they come to that conclusion? So the validity is the degree to which a measure accurately represent what it is supposed to, and the reliability is the degree to which the observed variable measure to the true and is thus error free. Okay, actually I'm the person yang kena tengok contoh. I'm not sure whether you are that kind of person, same like me, because from the sentence I'm quite lambat sikit nak dapat tangkap. So I use this something I have to find a figure to understand. That's me. Okay, so what we call the validity and what is the reliability? Okay, from this picture we know that this is not reliable and not valid anymore because it's separate and it is not on the target. Okay, what we call the reliable? Reliable is something closer to another thing, closer to one to another. Okay, for example, we produce one thing, which is we produce one car, but it is not fast enough. For example, our target is to make a car that can go fast, which is this fast. This is our target, is fast. But we produce a car, a new car, but the difference of measurement when we measure our car, it quite similar to one another, which is it is quite similar to other product. So that we can say that our car is reliable enough compared to other product. We not say that our car is good, but it reliable enough compared to other product. You get what I mean? And this is reliable and valid, which is it is closer to one another and it is on the target. This is reliable and valid. And this is valid, but it is not reliable, which is it closer to the target, but it is quite separate to another. The distance is far to one to another. Okay. Any question? If you see the physics one is this is like accurate, which is this is G2, persist, something like that. This is the term that that we learn in physics by using the textbook, Malay textbook, right? Okay, and we if you don't get what is reliability and validity, we can see from this video. Okay. Uh, okay. Sekejap ya. Okay, so I have to share and I have to open the sound. And this is the video for the reliability and validity. For me, if I learn something, I have to find some explanation. I will search for the image or I will search for the video so that it will help me to understand about that particular topic. Okay, can you see my video? Can you see my video? And can you hear the sound?
Reliability
Okay, so
refers to replicability. A test is reliable if it measures student achievement consistently, whether the student takes the test in the morning or afternoon of the same day or a day or two later. Another measure of reliability is internal consistency, whereas students' performance on comparable items on a test should be similar. Finally, alternate form reliability ensures that two forms of the same test are very highly correlated. Values for reliability coefficients range from 0 to 1. A reliability of 0 means no reliability, and 1 means perfect reliability. Due to measurement error, perfect reliability never happens. Generally, if the reliability of a standardized test is greater than 0.8, then the test is said to have very good reliability. If it's below 0.5 reliability, it would not be considered a reliable test. Validity refers to the accuracy of an assessment, whether it's aligned to theoretical constructs, content, and scores on other measures or future measures. A test can be reliable, meaning you get the same scores if you retake it, but not valid, meaning that the test doesn't measure what it's supposed to measure. Thus, it is important to ensure assessment validity and reliability.
okay. So far so good. Back to our PowerPoint. Okay, this is further explanation about reliability versus validity in the research. Okay, reliability versus validity is a complex topic that is useful in evaluating the quality of research while creating a research design. It is important to understand the difference between these terms. Okay, so in the research, if we call it reliable, it is when the research recall under the same condition. Reliability tells the extent to which results are reproducible. Okay, then when it is validity, the result of the validity depend on what they are supposed to measure. Then for the number 2, which is in this in one research, it is reliability is assessed by checking the consistency of result across time, observers, and part of the test itself. And for the validity is assessed by checking how well the result correspond with the established theories. And number 3, the third one, the result of the reliability might be reproducible, but it does not mean that it will necessarily be correct. And a valid measurement is always reliable. It means if the test results are accurate when it is reproducible. Okay, this is when we call it reliable and when we call it validity in our research. Okay, this I'm taking from the notes from the homeworkjoy.com. Then for the statistical significance and power. Okay, in this statistical significance, we have type 1, type 2 error, and power. What is type 1 error? Okay, type 1 error, we represent it as a alpha. Alpha is type 1 error here, type 1 error, alpha. Okay, is the probability of rejecting the null hypothesis when it is true. Okay, this is null hypothesis. When it's true, it is reject H null, it is alpha. Type 2 error or beta is the probability of failing to reject the null hypothesis when it is false. Okay, this is the fail to reject H null and it is false, H null false. This is what we call the beta type 2 error. And for the power, okay, is the probability of rejecting the null hypothesis when it is false. Okay, understand or not? Okay, we
Confused.
confused, right? Okay, it's okay. First, when we read it first time, we will be confused, but it is a good sign. Okay, we try to understand. And this is what we call a type 1, type 2 error if we have the curve like this, which is this is null hypothesis and this is our alternative hypothesis, and type 1 error involved here. And for any mean, this is our mean value and this is the type 1 error and the type 2 error will fall in this area. Okay, it's okay if you not understand yet, but for the machine learning class after this, you will see the confusion metric. When you see the confusion metric, it involves the true positive, it involves the false negative, true negative, or false positive. It is type 1 and type 2 error. Okay, for example here, true positive, correct conclusion. If one lady, the pregnant lady come to the clinic, then the doctor diagnosed that she pregnant. So it is true positive because that lady already pregnant and the diagnosis is she's pregnant. But this is what we call false negative. The pregnant lady diagnosed by you are not pregnant. This is what we call a false negative. In the machine learning class, you will learn about this. This is one type of, this is the example of this table just now, this table. Okay, then if a guy come to the doctor, it said that you are pregnant. So this is the situation when it is false positive. And for the true negative is the guy memang tak boleh pregnant lah kan. That's the true negative. Okay, then we will I attach this video to make you more understand. Okay, and you hear the
New
sound.
power servers work intelligently and
Okay, so we can
collaboratively.
see this
Minus
video.
beta.
Okay, so the example is quite simple, and I found this video very interesting video.
In this lesson, we will learn about the errors that can be made in hypothesis testing. In general, we can have two types of errors, type 1 error and type 2 error. Sounds a bit boring, but this will be a fun lecture, I promise. First, we will define the problems, and then we will see some interesting examples. Type 1 error is when you reject a true null hypothesis and is the more serious error. It is also called a false positive. The probability of making this error is alpha, the level of significance. Since you, the researcher, choose the alpha, the responsibility for making this error lies solely on you. Type 2 error is when you accept a false null hypothesis. The probability of making this error is denoted by beta. Beta depends mainly on sample size and population variance. So if your topic is difficult to test due to hard sampling or has high variability, it is more likely to make this type of error. As you can imagine, if the dataset is hard to test, it is not your fault, so type 2 error is considered a smaller problem. We should also mention that the probability of rejecting a false null hypothesis is equal to 1 minus beta. This is the researcher's goal, to reject a false null hypothesis. Therefore, 1 minus beta is called the power of the test. Generally, researchers increase the power of a test by increasing the sample size. This is a common table statisticians use to summarize the types of errors. Now, let's see an example that I heard from my professor back when I was studying statistics in university.
You are in love with this girl from the other class, but are unsure if she likes you. There are two errors you can make. First, if she likes you back and you don't invite her out, you are making the type 1 error. The null hypothesis in this situation is, she likes you back. It turns out that she really did like you back. Unfortunately, you did not invite her out because after testing the situation, you wrongly thought the null hypothesis was false. In other words, you rejected a true null hypothesis and lost your chance. It is a very serious problem because you could have been made for each other, but you didn't even try. Now, imagine another situation. She doesn't like you back, but you go and invite her out. The null hypothesis is still, she likes you back, but this time it is false. In reality, she doesn't really like you back, that is. However, after testing, you accept the null hypothesis and wrongly go and invite her out. She tells you that she has a boyfriend that is much older, smarter, and better at statistics than you and turns her back. You made a type 2 error, accepted a false null hypothesis. However, it is no big deal as you go back to your normal life without her and soon forget about this awkward situation. Hypothesis testing is usually like that. You don't really want to make any of the two errors, but it happens sometimes. You should be aware that statistics is very useful, but not perfect. Alright, that's all from our love/life/statistics lesson. Thanks for watching.
For more videos like
Okay. Does this video increase your understanding? It helped a bit, right?
Yep.
Maybe you if you want to more understand about this situation, the example just now, please plot it. Which type 1 error is here, which is he don't invite even though the woman love her back. This is the type 1 error just now. Put it back in this table. Then you can find that what the fail to reject rational mean and what reject rational mean. That's more easiest. Okay. Then I will continue our lecture. Okay. So this is what the type 1 and type 2 error, and this is power. Okay, power is determined by 3 factors. What is power? It come from the effect size, it come from the alpha, and it come from the sample size. What is the effect size? It is the actual magnitude of the effect of interest. For example, the difference between means or the correlation between variable. And the alpha is the set of smaller level power decrease. Typically, alpha is equal to 0.05. Then just now the video said that the alpha is we as a researcher will set. Then this is the sample size. As sample size increase, power increase. With very large sample size, even very small effect can be statistically significant, raising the issue of practical significant versus statistical significant. If you can see in this table, the effect of the alpha. Okay, this is alpha 0.05. Okay, effect of the sample size versus the alpha value, and this is the effect size which is small, moderate, and this is for the alpha 0.001, small and moderate. We can see that if we increase the sample size, we begin with 20, and with alpha 0.05, we have this effect 0.95, 0.338, and we found that if our alpha is quite small, and we found that the effect size here from the small is 0.25 and 1.44. But when we increase the sample size, this value also increase, and until we increase 200 and the value keep increasing. Okay, that's the effect of the sample size for the power level. Okay, this is if we graph it, this is the alpha 0.05 and 0.1. We can see that the power will be increased if we increase the sample size per group. Okay, and for further explanation for this topic about type 1 error, type 2 error, and the power, you may see from this. Just now I put the link. Okay, wait for the. Okay, this is Khan Academy. You may subscribe this Khan Academy. Actually, while I'm teaching calculus, the calculus for this faculty, most of them don't take the they don't take the add maths in SPM level. So I suggest for them to subscribe all the online sources that they know. And this is one type of online sources, and it is free. If you sign in, then you can see all the notes here and you can do the exercise. Okay, this is from the link that I attached. It will introduce you what is type 1 and type 2 error and example identifying it, and then the practice. Okay, you can do the practice for type 1 and type 2 error. They give you the situation and you have to decide which one is type 1 error here. And they also have hint. Okay, you can go through. This is one of the example from the
What we are
Khan
going to
Academy.
do in this video.
Okay, this is introduction to power in significant test. What is the power means? And this is example of thinking about power in significant test. You can get more information from here. Then this is the practice. You can you may try this practice after this. And lastly is the consequence of error and significant. What this mean? Okay, this is the review and this is the example. Then you may check your answer. Okay, this is one type of one source that we may use in our study. Okay. Okay. I hope it will help you while you are studying. It's not on the statistic, but on other lecture also. Don't depend on the slide, but you may find other sources. Okay, in my masa zaman saya, I will go to the library and borrow all the book, all the tebal-tebal book tu. Then your zaman ni dah quite easy because we can find all the sources in the internet. Okay, we also have the ebook from the internet. Okay, then back for the I will not explain, but you can go through all the slide here. Okay. Okay. Is it okay? Okay, this is statistical power analysis. If you need a break, please let me know. I know that you are working today, right? And you have to attend class in the night. Quite tough, actually. Same with me. Okay, this is statistical power analysis. Okay, rule of thumb. What you have to know in this statistical power analysis. First, researchers should always design the study to achieve power level of 0.8 at the desired significance level. More stringent significance level, example 0.01 instead of 0.05, require larger sample to achieve the desired power level. And conversely, power can be increased by choosing a less stringent alpha level, for example, 0.1 instead of 0.5. Okay, smaller effect size always require larger sample size to achieve the desired power, and any increase in power is most likely achieved by increased sample size. Okay, this is the rule of thumb of power and the statistical analysis. Okay, this is the example. I found it from the statistics teacher. Okay, if we have this, how can we decide? Okay, for example, if this is start from here, is the outcome statistically significant different? If p value less than alpha or less than alpha, then we may stop. And if the p-value is greater than alpha that we set, then we have to go to another step. Okay, if our case is no sample size of our calculation can determine if p is greater than 0.05, is from lack of power or true or no different, we will stop here. Okay, then this is the case where power calculation give power less than 80%, then study under power, sample size inadequate, can determine if P is greater than 0.05, then lack of power or true no different, then we will stop. Okay, this is like something flow that we can refer. Okay, for instruction, this is the start and we get the blue sign to stop, and we can continue if this case, then we may stop until this. Kalau if there is no it's not this case or this case, we may continue until we have this situation. Okay, then we stop. Okay, this is the note. Okay, here you can see from the statistic teacher, they give you the case study, then you they guide you how to determine it. Okay, this is from the website that I shared just now. Okay, this is the explanation about power, and this is the primary factor about power, which is significant level, sample size, variability, variance, magnitude, and this is the chart that I showed just now. And you can uh, study this chart from the example of the application that they give you. Okay, this is 6 case study, and how they conclude. Okay, so in the study A, okay, this is the alpha 0.05. Then the result is student with stat master has been mean score of 92%, while student without stat master has mean score 85%. The difference was statistically significant with p-value 0.034. Okay, this is alpha 0.05, and this is our p-value. Then we found that our p-value 0.034 is less than 0.05, where this study A will locate at this stage. Kat sini. Then it may stop. Okay, you can find further explanation how they conclude. Okay, this is how they conclude. And for the study B, where the study B located in this chart, then how they conclude, you may see from this explanation. Same goes to the study C until study F. Okay, you may go through this after this, how they conclude. Okay, but first I want to know, did you know what is the p-value mean? P-value. You know? Okay. Actually, the p-value is, we want to know the difference, the significant difference. From here, we found that significant difference is 0.034. It comes from the mean score for this stat master 92%, while student without stat master have 85%, which is, there is different. Student with stat master and student without stat master, we know that by using this stat master, it increase their score. Okay. Okay, I will bring the p-value. Okay, you may go through this case one by one after this. Okay, I will stop. Okay, I'll go back to the slide. Okay, I will explain. Okay, in my case, for example, for the p-value p-value. What is the p-value in my study, for example? Okay, I produce one, for example, I produce one modification of age detection in image. Okay, this is, kejap, dia tak ada, tak apa I will counting dekat atas ni. Okay, I propose one technique. This is proposed technique by me. Okay, I propose one technique by using my algorithm to find the region of interest in one image. For example, this is the image and I want to find region interest of the eyes. Okay, in the person face, I will find eyes in the person face. Okay, this is a region of interest that I the proposed technique to find the region interest by using my algorithm. Okay, this is the result that I get from the 200 image, for example. 200 image. I have, okay, all the image is about 200 image. But how can I say that this study is significant enough, significantly, which is valid? I have to compare with the previous technique. For example, I take the previous study. This is previous study. This is tulis If I am not tulis nanti lupa. Okay, this is from the previous and this is from me. Okay, then this is the previous study. They also want to find the region of interest and they also want to find the region interest of the iris in the image, in the face. Okay, they also use this 200 image. Okay, similar like me. And this is the result that I get from the ROI value and this is the result that they get. Okay, after comparing with the ground truth, I get this result. Okay, this is the accuracy that I get and this is the accuracy that they get from the previous result. Okay, how's the p-value? I have to calculate the p-value. Why I have to calculate the p-value? Because I want to conclude something. Okay, for example, in this particular image, they get the accuracy about 0.7 and I got the accuracy about 0.69. I'm less than them. But in the second image, their accuracy is about 0.65. But my accuracy is about 0.69. Sometimes I will go, I will higher than them, but sometimes in the same image, they higher than me. Okay. To all the comparison, if my p-value is 0, for example, is 0.03, I found that my p-value is 0.03, which is, it is lesser than 0.05. I'll put the alpha for my study is 0.05. Okay, then I conclude that my study is significant enough compared to the previous study, which is I have the significant difference, which is my value is significantly valid compared to the previous. Can you understand? Which is we can't find the value, the difference by looking at one by one. If we have 500 image, how can we measure? This is where the p-value can help us. But whether our study is significant or not. Okay, sometimes we get the value is about 0.75. Okay, we can find that we can conclude that our proposed technique is not significant enough because the difference is about 0.75. Dia tak ada bagi satu impact yang besar pun dekat that particular area. Can you understand or not? That's the thing that I use for the p-value to determine whether my study is significant or not. You may use all the software to to calculate for you if you have a lot of data to find the p-value. But for the p-value, you may find from the internet how to find the p-value, the fundamental, which is the calculation to find the p-value. Dalam buku that the Dr. Sek give to you is also have how to calculate the p-value. But now if we involve in many if we involve in a lot of data, we can't calculate one by one, but we can use the tool like SPSS R to calculate p-value for us. And we can conclude something if we found that the p-value is less than alpha that we put. Usually alpha is 0.05 or 0.01. Okay, the lesser the p-value that we get is the significant study that we propose. Okay. So far so good. Okay, we may continue. But here is about the overview. Okay, but in the exam we will not ask you how to design this multivariate data analysis. For this case, is not like that. But we have to know the overview of this multivariate technique because it we frequently will face this kind of this type of analysis. Okay, so this is type of multivariate technique, which is dependent technique. It's consists of two type, which is dependent technique or interdependent technique. What is dependence technique? A variable or set of variable is identified as the dependent variable to predict, explained by other variable known as independent variable. Okay, this is the technique that fall into dependence technique, which is multiple regression, multiple discriminant analysis, logistic regression, multivariate analysis of variant. Okay, after this, we will I will teach you analysis of variant. Then we will cover a bit about multivariate analysis of variance. Okay, what is the example of this case? And we will cover after for the next chapter. Then conjoint analysis. This is the technique that involved in the dependence technique. And other than that is canonical correlation and structural equation modeling. Okay. For this kind of technique, for example, Dr. Fauzia will touch a bit on multiple regression, something for the PCA. For example, this is for principal component and common factor analysis. We will not cover all, but we will introduce to you some of these techniques for the further class. Okay, then this is the type of multivariate technique for interdependence technique, which is involve the simultaneous analysis of all variable in the set without distinction between dependent variable and independent variable. For example, principal component and common factor analysis, cluster analysis, and multidimensional scaling, perceptual mapping, and correspondence analysis. And to select a multivariate technique, we have to know what type of relationship is being examined. And in that relationship, fall into dependent or interdependence. After we know the relationship, we have to know that how many variables are predicted, what is the measurement scale of the dependent variable and what is the measurement scale of the predictor variable. And then interdependent relationship, are you as a meaning relationship between reliable respondent or object. Okay, interdependent relationship. Okay, after this, in the next chapter, we will learn about analysis of variance. We want to know the interaction between one variable to another variable, one factor to another factor. Okay, this is two broad type of multivariate method, which is dependent and interdependence. Dependent analyze dependent and independent variable at the same time. But for the interdependence, analyze dependent and independent variable separately. Okay, then this is the chart that we use to determine if we are involving in multivariate method, whether we are in the dependent or interdependent, and if we are in the dependent, we have to know is our study is one dependent variable or it takes several dependent variable. It involves several or one dependent, or it is interdependent. It involve metric or it involve non-metric. For the metric just now, we are using if it involve metric, there is two type. There is about three type of analysis, which is factor analysis, cluster analysis, and metric. This chart will help you to determine which analysis that we want to do next. Okay, if the data type for this interdependent is non-metric, then we have to do the non-metric MDS and correspondence analysis. And this is the type of analysis. If one dependent variable, the data is metric, it is multiple regression and conjoint. And for the non-metric is discriminant analysis and logic. And metric is MANOVA and canonical, and non-metric is canonical correlation dummy variable. And it will get it may the multivariate method can be hybrid between dependence and interdependence, which is we call it as multiple relationship structural equation, SEM and CFE. This is the two analyses that we may use to analyze this relationship structural equation. Okay, and this is the explanation about multiple regression. What is multiple regression? Okay, this is quite an overview. What is multiple regression? Okay, it is a single metric dependent variable is predicted by several metric independent variable, and this is the single one, and it predicted by several metric independent variable. Okay, we want to predict it by several metric independent variable. We use multiple regression. Then for the discriminant analysis, okay, this is the definition. It is single non-metric categorical, and dependent variable is predicted by several metric independent variable. Okay, we are using this discriminant analysis for the gender. For example, man versus female, okay, culture, USA versus outside USA, and for the purchaser versus non-purchasers, and member versus non-member is like a categorical, right? Good, average, and full credit risk. Okay, this is we use for this kind of analysis, we use discriminant analysis, and this is the logistic regression. Okay, now I will explain overview about each technique that are using the interdependent and dependent just now. Okay, this is come for logistic regression. This is a single non-metric dependent variable. It's predicted by several metric independent variable. This technique is similar to discriminant analysis, but relies on calculation more like regression. Okay, you may see example for this. While if you search example case study for logistic regression for the MANOVA, okay, this is the several metric dependent variable are predicted by set of non-metric categorical independent variable. After this, in the chapter analysis of variance, I will teach that chapter. I will introduce to you what is MANOVA. Okay, then we will explain a bit furthermore in that chapter. Okay, then canonical analysis. This is the several metric dependent variable are predicted by several metric independent variable. Okay, and conjoint analysis. It is used to understand respondent preference for product and service. In doing this, it determines the importance of both attribute and level. Okay, based on the smaller subsets of combination of attribute level. Okay, and this is conjoint analysis. Okay, typical application of this analysis like a soft drink, candy bar, cereal, beer, apartment building, condos. We want to analyze. Okay, solvent or cleaning fluid, and this is what structural equation modeling. If you want to estimate multiple interrelated dependent relationship based on two components, whether measurement model or structure model. Okay, you don't have to remember all the technique. What because we can refer to the all the sources while answering the lab session and the project also in the midterm. Okay, but this is the overview. I will not ask you to explain one by one and what is the design for that. It's not like that. Okay, this is like an introduction. What is multivariate data analysis about? Okay. Then this is exploratory factor analysis. Okay, maybe Dr. Fauzia or Dr. Azra will cover on this. Analyze the structure of the interrelationship among large number of variables to determine a set of common underlying dimension. Okay, for this subject, statistic, we will not cover all the technique, but we will explain a bit on the certain technique so that after this, if you found the data type that are similar to one analysis, you may study and you will the explanation about some technique in this course will help you to understand other technique. Okay, this is for cluster analysis. Okay, cluster analysis, we want to group object. For example, for the respondent, product, firm, variable, so that each object is similar to other object in the cluster and different from object in all the other cluster. We want to do a clustering. We want to cluster. Okay, then this is the example of cluster analysis question. For example, I eat at a fast food restaurant at least once a week. I prefer to go to restaurant with the higher quality food, and I prefer to restaurant that have quick service. This is like cluster analysis. We want to know the in that particular area, for example, we want to build one restaurant. What type of restaurant that we want to use? First, we have to make a cluster analysis. We want to know the type of people in that area. Okay, we want to identify group for that area people so that it will help us to make a prediction what restaurant that we have to build in this area. Okay, this is what the cluster analysis. Okay, then the cluster analysis contract, trust, commitment, cooperation, locus of control, job satisfaction, turnover. Okay, this is organizational commitment. Okay, whether it is high, medium, or low. If we take out the medium, and this cluster analysis, we call it as a polar extreme, which is it has only two group, which is high and low. Okay, this is multi-dimensional scaling. It identifies unrecognized dimension that affect purchase behavior based on customer judgment, which is like a similarity or preference, and transform this into distance represented as perceptual maps. Okay, this is the overview about multi-dimensional scaling. analysis. Okay, then correspondent analysis is use non-metric data and evaluate either linear or non-linear relationship in an effort to develop a perceptual map representing the association between object and a set of descriptive characteristics of the object. And this is the guideline for multivariate analysis. Okay, if you have this kind of analysis, first you have to establish practical significance as well as statistical significance. Then you have to know your sample size, effect, or result. And you have to know your data. Strive for model parsimony, then look at your error. Okay, then after you get your result, please validate your result. Okay, this is the guideline if your study involved in multivariate analysis. Then this is a structured approach to building to build a multivariate model. Okay, first stage you have to define research problem, objective, and a multivariate technique to be used. Okay, then you have to develop an analysis plan. The stage 3 is evaluate the assumption underlying the multivariate technique. Then the stage 4 is estimate the multivariate model and assess overall model fit. Stage 5, interpret the variate. Then stage 6 is validate the multivariate model. Okay. Then this is the example. Okay, this is the data. You know the data here. You have to know your data. Okay, this is variable description and this is variable type. Okay, then this is the multivariate analysis checkpoint. What you have to do is what is multivariate analysis, and okay, for this chapter, what you have to know, what is multivariate analysis, why use multivariate analysis, why is knowledge of measurement scale important in using multivariate analysis, then what basic issue need to be examined when using multivariate analysis, and describe the process for applying the multivariate analysis. Okay, this is the end of the slide for this multivariate data analysis, introduction to multivariate data analysis. I'll put some study and example for this analysis. For example of multivariate analysis from market research company Central New York. This is the example that I found in the internet. They are using multivariate analysis. Okay, we go one by one. You may go through. Okay, this is their report. Okay, their example. They are using multivariate analysis. Okay. Okay, this is 3 example. Is multiple regression and four-joint analysis and discrete choice modeling. Okay. This is the 3 example for multivariate analysis that they use. And for the next is 11 multivariate analysis technique. Okay. Internet quite slow. Are you okay? Are you with me? Do you need some break? So far so good. Okay. This is 11 multivariate analysis technique key tool in your marketing research survival kit. Okay, this is an overview and this is initial step, which is data quality. We have to know our data first. We have to examine our data. Okay, after this, 9:23, so we will finish on 11 o'clock. Okay, for lab session, we will know about we will study about how to uh, know our data, which is how to explore, how to make our data clean, and how to tidying our data. Okay, that's the first thing that you have to do before before you analyze your data. You have to examine your data first. Important to understand magnitude of missing value in observation, determine whether ignore them or input value of observation, or if you want to split the data first. Okay, first is to clean your data. Before you have to clean your data, please how you want to write or how you want to read your data. Okay, we don't want to do it manually. We want to use tools to help us to clean our data, because if we facing a lot of data, we can't do it manually. Then here they discuss a bit of multiple regression analysis, logistic, discriminant analysis, and MANOVA, and so on. Okay, this is from the this 11 multivariate. Okay, this is which multivariate data that we want to use. Okay, this is an example from their finding, which is if our data is quantitative variable only, okay, and it is exploratory, we have to divide our question. Okay, this is if our survey is for exploratory, we want to explore first. Then if our survey on decisional, we want to make a rule, we want to make satu akta, for example. Okay, it will fall under decisional. Okay, what type of data description that we use? Okay, for example, quantitative variable only. Then the tool that we may use is PCA. Ni dia dah bagi tahu. This is the example. And the remark here is consider all the variable in data component do not necessarily reflect real phenomena. Okay, this table is quite membantu. If you have this type of question and you have this type of data, then what analysis that you want to consider? Okay, for example, if it involves contingency table, two qualitative variable, you have to use correspondent analysis. Okay, the explanation of correspondent analysis you will find by clicking this link. Then if our number of table is greater than 2 or equal to 2 and it is exploratory and our data description is qualitative variable table or quantitative variable table or frequency table, we have to use multiple factor analysis. Okay, this is how they table it in this table. They help the researcher to decide. Okay, then if our exploratory to cluster something and it involves the quantitative variable, you may use clustering tool such as AHC, K-means, and others. Okay, we see and classical clustering method could be applied on the quantitative variable table indirectly using row score and dimension of multiple correspondent analysis. Okay, and so on. If you make a decisional for the causality, then it involves more than 2 or equal to 2 number of table, then you this is the data distribution, and the possible analysis is partial least square structural equation modeling. Okay. Then this is the latest one is about in last year, 2020, they are using this study, which is the Pfizer case study leveraging multivariate analysis. They are using multivariate analysis for this Pfizer case study. Okay, the initial diagnostic and process understanding. Okay. go through this, what they do, and this is the limitation of multivariate analysis, and look at a case study. Okay, first case study. This is the scope and description and what the outcome. Okay, you may see a lot of example by using multivariate analysis in research. Okay. This is the table, score scatter plot comparing API metric for two suppliers. You want to know whether it is far to one another or something. We want to measure. Okay, this is the case study 2. Okay, end of this chapter by looking at the example just now. Okay, maybe we want to take a 10 minutes break. Is it, do you want to take a break or we want to continue? Or about 5 minutes only? Nah, teruskan.
Sorry, doctor. We will have the next lecture.
We have a lab session. Do you, okay, before we go for the next, which is how we read a table from the R. Okay, that's the next session, our lab session. Did you start, did Dr. Sek explain it to you in the Dr. Sek class? How to read the data? Did he explain to you? Because, okay, this is the you learn. Okay, the important thing that you have to know is, okay, quite sure Dr. Sek already go through this. Okay, we have to enroll under Fauzia MTGS 5133. Okay, can you see my ULEN? This is the ULEN. Okay, this week 1, week 2 is under Dr. Sek, and this is our here. Okay, this is the recorded lecture for the full-time student that I put here. And after this, I put the recorded for your class. Okay, if you want to see their class in your session, it's okay. If you want to go through my session back, you can go through after this. And this is the R material that I put from my Dropbox. Okay, please download it first. Okay. Okay. R, you already use R in the Dr. Sek class, right?
Yes.
Yes.
Okay. Okay. So, for my class, please download this R material. Okay, in my class, we will cover on the read, write, and how to clean our data, how to find the missing value, and how to tidying our data. Okay, that's the next thing that we have to learn. Okay, but before we go to get that particular lab, okay, this is the assessment. Okay, you can see that this is the project and lab assessment. Okay, it is hidden from student. Okay. Okay, for the lab assessment, you do it, it will open on 19th January. Okay, okay, it is, can you see this lab in your lab? Actually, Dia tutup ni. Okey. Sekejap. Saya rasa saya boleh buka.
Can see.
Can? Okay, can see. Kenapa dia tulis dia hidden from student? Okay, so this is the lab assessment. Do you do it individually? Okay, this is the lab. And this is raw data and car. And you have to do it individually. You can see the question from the lab assessment. You may answer the question that you already learned. You need to wait until Dr. Fauzia finish her lecture to answer, because some of question is come from Dr. Sack and some of the question come from me. Okay, maybe you can see this lab question. Okay, you have to use the R Studio to complete this lab assessment. All R code must be shown clearly. Then this is the question 1. This is the table that you have to use. Okay, this is about the quantitative and qualitative variable. Okay, and you do it individually. If you have question regarding my topic, okay, my topic is for the question 3. This is my topic. This is the question that I made. Okay, I'm not sure. Maybe question 1 and question 2 is from Dr. Sack. Okay, if you have question 1, question 2, then you may refer to the Dr. Sack. And this is question 3. This is from me. Okay, this is the question attach this data, lab raw data.csv. Okay, so make it bigger. Okay, so before you can utilize or visualize and analyze this, you have to familiar with the data set. You have to know your data. This data, you have to open it. Okay, read it by using R. Okay, then after you read it, then check for structural error. What is the structural error? You have to know whether in the one column too, is there any mix between numeric or character data, or that's a mix between data. You have to clean it first. Okay, that's the next lab that I want to teach, which is how to tidying our data. Then we have to check and handle data type error. That's the data type error, how to handle it, and how to deal with missing value. It is up to you whether you want to make this missing value. You want to find this missing value by putting one value to that missing value. Missing value can be, if your data in the data can be NA, or it doesn't have any value, totally it blank in that particular box, or missing value can be missing there. The word missing, that represent the missing value also. That the 3 type. How you deal with it, whether you want to take it out or something like that, that's you decide. Then split up field that contain multiple value in a single field. For example, there's one column, there is involve date, it involve time, and it involve day, which is for example date 29 December 2020. Then there is 9:30 p.m. and Wednesday. There's 3 things in one area. You have to split it or not. You have to decide. Okay. Then after that, maybe you have to split it to conclude something. Okay, all the thing that you do in that particular data, you have to document it, how you clean the data. If there is involved splitting, and if there is involved missing value, how you tackle the missing value problem, and the changes made, you have to document it. Then you have to then that's the question 3 all about. Okay. Is there any question? This is a question 3. And question 4 is also from me, that we will learn this on the next topic, which is analysis of variant. I'll give you the link here. This is the link for the data and how you read this data from the link to analyze it in R. Okay, you may use the read function to read this and how you clean this. Okay. Then this is a question 3, a question 4, and answer from this how we want to conclude our study. Then we want to put another variable. If you put another variable, and what the conclusion that we found from that. Okay, so this is question 3 and question 4 for me. Okay, after finish my class, maybe you can answer 1, 2, 3, 4. Then wait for Dr. Fauzia. And no need to wait until Dr. Fauzia finish the class. Okay, you can answer the specific question that you already learned. Okay. This is the lab assessment, individual, and then the project for the grouping. Where is project? Assessment, and this is project. This is the group. Okay, you may see this. Okay. This is group. Dr. Sek mentioned that maximum is 4% for one group, right?
Yep.
Okay. Now this question you can answer after finish Dr. Fauzia class. Okay, so the first thing that you have to do is settle the lab assessment. After finish one topic, you can answer. Okay, for my class now, you want to continue or you want to stop? The army cleaning data, tidying data, we do it next week. Macam mana? You decide. Then another 2 class, we focus on analysis of variant. Analysis of variant tu banyak juga. Okay, this is the first. I want to focus on the read and applied statistics. Okay, this is how we read and write data from the R. Okay, this is how we save and load data from R. There are many ways to get into R, out of R. Okay, you can. This kita nak masuk ke tak ni? Do we want to explore this or not? Or we want to do it in next class? Kita banyak sangat rasa.
Sorry, I cannot absorb already.
I understand. That's why I ask you. So we will go slow and steady. Maybe for next class we focus on how to read, write, and focus on R from the R material that I put in the ULearn. It's okay. Okay. Then the next class on the third meeting which is on the next week. Okay, we'll focus on the analysis of variant. And analysis of variant part 1 for the Tuesday class, and analysis of variant part 2 on the Thursday class. Okay, so we don't mix. So for my lab assessment just now, you cannot answer it yet because we will learn about read and write and tidying data in the next class, which is in the Thursday class. Is it okay? Next class. Okay. Faham. It's okay. Kita boleh bincang. Okay. So the last session. I want you to open your camera. Can or not? I want to know my student. Really miss to meet my student. Actually, for this semester, I teach calculus for diploma, then ada business maths for the degree. For apa? FPTT. FPTT ialah faculty technopreneurship. FPTT. Okay, yang lain tak ada ni ke? Can you open your camera? Okay, hi. Syufan. Okay, Sim, Huzaifa. Okay, Iza. Iza Nosharin ni nama ke bukan? Siapa nama sebenarnya? Tak dengar ya.
Iza, you mute leh.
Mute. Nama sebenarnya Iza Nosharin ke? Tak dengar.
Yeah, that's his name.
Oh, okay. Saya ingatkan tadi perempuan. Itu sebabnya nak kenal muka. Okay. Aiman, where are you? I want to see your face.
Aiman bukan dah kenal ke?
Yelah dah kenal, nak tengok juga. This is the first class, so we will meet again next class. Nak tengok lah, tak adalah every week kena buka kamera, tak lah. Malam ni je. Nak tengok student saya. Nizamuddin, Syahira. Just now ada seorang tu, dia kata dia ada interview. Kena ada assessment malam ni, so that he will follow the recorded version. Okay, so yang lain tak nak buka, tak apa nak. Okay. Aiman, tak nak kan? Okay, Nizamuddin. Okay.
On the way.
Oh, semua okey, semua sihat. Maksudnya ada dekat ada yang dekat kawasan banjir ke tidak ke? Ada terlibat dengan banjir. Okay, alhamdulillah. Because even though you are doing master, but we ada satu center yang memang nak tahu the student yang facing the banjir tu mungkin ada something yang diorang nak kasih. Itu kan ada kita punya kebajikan punya ni. Okay, so Hamidah, Lim and Syaira, maybe they have problem with their camera. So sebenarnya nak ambil gambar. Okay, ready?
Aiman dah buka.
Aiman dah buka Okay, 1, 2, 3. Okay, kejap. Sekejap ya. Okay, another one. Kejap. Okay. 1, 2, 3. Okay. Thank you so much. Then we see on next class on Thursday. Okay, thank you.
Thank you, Doctor.
Thank you, Doctor.
Thank you.
Thank
Bye-bye.
you, Doctor.
Bye-bye.